Welcome back to Chem 4300. In this video, we're going to look at a web app written by Paul Falstad that nicely illustrates the waves that occur on a rectangular membrane. So before I look at the app, I'm going to go back a couple slides here and remind you of the result that we obtained. We found that the normal modes of a rectangular membrane are given by this equation here. What's important to notice is that there are two indices here, n and m, because now we're in two dimensions, that are used to label the different modes that are possible on this membrane. And any wave that appears on this membrane can be written as a linear combination of these normal modes. So taking this expression here and doing some linear combination with various amplitudes here, we can construct any wave that occurs on that membrane. Now, we can also do a Fourier series analysis on our wave function, plugging it into here, and this is the result from Fourier analysis that tells us what the amplitudes are for each of those normal modes. So if I go to the next slide, this is where we looked at where the nodes are, that is the point where the wave function changes sign from positive to negative and vice versa, and we looked at the regions that had positive and negative signs. So this is the example where we go across with m going across the top and n going down. These are the indices labeling the different normal modes, and these are what the sort of shapes of these normal modes look like, but it really only shows us whether they're positive or negative and where the nodes are. So what's nice about the simulation is we'll be able to see the full amplitude and the time dependence of these waves. So let's take a look. So here is the app running, and when it starts up, it shows you just the fundamental. So the m equals 1 and n equals 1 normal mode. So that's indicated here. So this corresponds to m going across this way and n going across that way, or going down this way, I should say. And so this means that we've excited the fundamental. I can turn it off, and now the membrane is at equilibrium. There's no motion whatsoever. If I push this button here, it just re-excites the fundamental. But I can turn this fundamental off, and I can go over here to say m equals 2 and n equals 1, and we can see what that mode looks like. So this is the m equals 2, n equals 1 mode oscillating, and it's as we expected from the picture that I had in the slides, but now we can see it sort of real time. I'll turn that off and we'll go to the next, m equals 3, n equals 1, and now you see the two nodes here, and you can see the opposite sign. So when this side is this section is opposite sign to this section, which is opposite in sign to that section. Again, I can turn this off, and you can see the pattern that emerges as we continue to go up the values of m with n held constant at 1. Similarly, we started over here at the fundamental and we went down to increasing n. You can see that all we're doing is changing the shape, but now it's sort of rotated 90 degrees and we're getting the same kind of pattern that we saw with increasing m. It's a little bit harder to see, I think, from this angle here, but I think there's an ability to change the view angle, and you can probably rotate it around and see it here. So continue going down like this. You can move and create any of these shapes. Now you can also do some mixed values of the m and n. So here's m equals 2 and n equals 2, or m equals 3 and n equals 3, and so on. So this is worth playing around and seeing what they look like. The other cool thing about this app is that with this thing set here at poke membrane, you can actually go over and grab the membrane and pull it up like you're going to sort of excite some kind of shape on the surface. So if I do this, you can see already that down below we see all the modes that are involved in creating this initial shape. So this is completely analogous to what we were seeing on the string. We pulled the string and we saw the decomposition of all the normal modes on the string. Now we're seeing the decomposition of all the normal modes on the membrane. And the green are positive amplitudes and the reds are negative amplitudes. So if I let go, then we'll see the wave propagate in time. And you see, of course, the normal modes are not changing because those amplitudes are just evolving in time, but we're not changing the size of these amplitudes. Now, if there was damping on, you can see there's a damping button here, we could damp the wave out. So eventually the wave would die out. So if I turn this up, I think eventually it should die out. But it seems to be happening pretty slowly. So I'm going to increase the simulation speed. There we go. And now you see that they eventually die. Okay, so I'm going to reload the app to the defaults here. Close this and reload the app. And let's try again then. So let's clear it. And now let's do other pokes. So you can see by different places I grab the wave, let it go. I create different linear combinations of the normal modes. I'll pull it again. I'll pull it down here. And you see what these shapes are like. So I'll leave it up to you to just go ahead and play around with this and sort of get a feel for what all of these shapes look like. And you can, again, you can adjust the view angle here and move it around and look at it. But this is a really great app to sort of just bring these ideas, make these ideas clearer in your head as you play around with changing the values here, for example, like that. Okay, that's it for this video.